Hello, this is Don Giserta coming to you from Control 2024. It's a very exciting exhibition this year for us as we are presenting a new level of integration between Metrology X4 and QDM. As we in the past have had file exchanges and worked on making those file exchanges more complete, we are now eliminating the need for files. We are directly communicating at the database level so that there is a seamless exchange of information between Metrology and QDM. This allows a continuous process flow. It allows for exchange of information to take place as changes are occurring during the product development cycle, and as those changes are necessary to be delivered to the measuring machine, they can be done in almost instantaneous fashion, and the data then collected and reported in the QDM environment with statistical process control for continuous process monitoring.
What is the value of a customer? The value of a customer is to simulate the quality even before a part gets produced or assembly gets produced, to figure out how the datum, the reference system should set, how the tolerance concept should set, how the values should set, that it's not too tight but even not too low. And very often when we are visit a customer, we find this situation here on the screen where they have a high risk of production due to that they have a huge big scrap and waste rate and a low first time quality. And this is mostly happen when the fixation starts at the manufacturing. So how can we turn around that? The point is we have to start quite early the production, and the production, what I'm talking about is simulation. So therefore, we don't call it tolerance calculation, we call it a virtual or digital prototype. Let's have a look to the digital prototype and how easy it is to set up such a simulation. So now we are in the CAD and we do have our parts, and we have inside the parts the 3D PMI, but we have also the constraints. So just making one or two clicks to hand over all the things we already create within our CAD tool. So hand over the 3D PMI, but also handing over how the part get assembled by the manufacturing. And now we are just make a nominal build to assemble that and run the simulation to figure out if the design strategy, the tolerance strategy, the measure strategy is exactly that what we need to secure our quality expectations. And then probably we find out that on our measurement, let me go to the right one, we face some out of specification. So, and what we also find is what are the guilty of that result. So what do we have to change? And it's just by a double click that we can change. So how is the normal behavior on the customer side? It's get idea, sending back to the tool will be changed. It takes weeks until you get the part back just to recognize, oh no, that's not the right direction, and you do it forever. And you can shorten that time dramatically just for seconds, because as I said, I just make a double click and I rerun the simulation, and then I compare to understand I am in the right direction or not. And it takes just some seconds, and I do understand I am right or not. And then what I can do with that, I then can push over that tolerance, and this tolerance will then be moved to the 3D part of the simulation or the 3D part, and will be placed here. And when the tolerance is then in the part, we can hand over to Planner X4 and go further for the measurement. And then the journey starts.
Okay, let's go to introduce you the end-to-end process from Metrologic. We are here to visualize the Metrologic hub, and we are going to focus on the planner activity where the inspection plan will be produced to activate the different phase, step 2, 3, and 4. Some information can come from the CAD system directly from the design, and some other can come from the 3DCS system. Let's see and discover what the planner is doing. So we open the environment, and we are here to define and receive the information from the design. So I'm going to open a CAD file. These CAD files can come from the design himself, from different CAM system. And as you can see, it's already get some information with the PMI information. So this is a GD&T information that we can explore through different functionality, and we see here there is around 21 characteristics that the user is going to prepare in this phase. So according to the value that we are here, according to the information we have on the CAD, we can use this kind of functionality that is going to explore the CAD and define all the features. So all the features is going to be extract from the CAD with only one click like this, and we have prepared all the features coming from this kind of characteristic, the feature of cylinder or some other GD&T information that the customers would like to address. As you can see here, we already see that this characteristic is completely credible because they are fully semantic for the characteristics. Let's go now deeper, because on this phase of prepare, we have already our inspection plan. This is all the feature we have to measure, but we are also the capability to prepare some different views and prepare that for the treatment of the information. Let me set few parameters to explore the value, and maybe I can prepare a view by selecting my features, making a right click here, and I already prepare my view in order to, when I will receive the characteristic from the measuring and the execution phase with online inspection software, I will be able to store, and I've got my view. Let's save this view. So, and I can remind this view according to the different application, and of course I will get this view. Now what will be the next step is to prepare my reports. It's automatically done because I received the view, I've got also the features, and if I go in my edited report, I got already the view with the stickers pre-placed with the different parameters, and I've got all the features I would like to measure. So everything now is saved, and I can now go to the step of the preparation and programming with Silma. So I can switch off and get the next step. So I will just save my inspection plan somewhere on my desk or somewhere on my database, and then I finish, and we can go to the Silma phase.
So here, this is Silma, so the offline simulation tool. Here you will be capable to recreate your environment in the simulation, what we call the digital twin. So here it's a CMM, but it can be also a robot, and we can also manage different technology like tactile or optical sensor also. Using Silma and its digital twin, you will be able to recreate the virtual cloud in order to anticipate the cloud you will have on the reality. So it will help you to prepare all the steps for the analysis offline and so on, to reduce the downtime on the real cell, because the challenge it's to stop the cell the minimum time in order to not stop the production. So here, this is Silma. You can see that we have our configuration. So here it's SP25 probes using a tool changer, but it can be different, any brand or any technology, because you are universal. And here we came in Silma with our inspection plan So this plan is coming from the prepare phase from planner, and here we will reuse the same plan. So the next step is to create the part program. So thanks to Silma, you will have the possibility also to use some smart tool like the inspection path planning. Using the path planning, actually, we will create in only few clicks all the part program with an optimized path, collision-free path, and so on. So the software will select for you the good tool in order to avoid any collision, and also the good head orientation, and optimize all the steps in order to have a good pass and to have the possibility to push it on the production. So here at the end of the computing, you have a sum up of what happened. And for example, you can take a look, but for let's say this feature, the software decided to use this probe orientation. But here, for this feature, inside here, you can see that since it is a tricky access, here the system decided to use another tool. So you can see here you have a sum up of which tool has been selected, which probe, and also the evaluation method, and if there is a collision or not. When you will validate this panel, here you will see inside the program all the lines coming here, and this program will be saved and will be sent to the next step, so in Metrology into the shop floor.
So we are on the Metrology execution of the end-to-end process. It gives us the possibility to run the programs that has been learned from Silma. And voilà. The benefits to use Metrologic is because we are a universal solution that can be and we can interface to every kind of system. Here, for example, behind me, we have the 5-axis system from Renishow. Metrology is connected to the I++ server of Renishow, and the benefit that we can supply to this solution is that we are bringing a really good user sharing experience thanks to our 40 years of experience in the metrology. For example, on this kind of solution of 5-axis or robot solution, it's difficult for the user to program because of the rotation and translation of the system. And what's the pre-value of Metrologic is to bring graphical tools and intelligent automatic path measurement to help the customer to exploit the maximum capability of this kind of solution. And so, thanks to after that we have generated the program, Metrology is going to connect to every kind of system and to run the program with the most optimized time cycle. The benefits to use a 5-axis system is to save a lot of time for the customers and to increase the productivity and to succeed to measure the maximum parts and to have the purpose of using Metrology is to be able to measure 100% of the parts that the customer is producing and to be as much as possible focus on the one-line inspection.
Okay, so here is the new machine from DWFRITZ and Metrology. It's the zero-touch machine. So the target of those machines is to inspect 100% of your parts. For years, industrial decided to have automated cells, but one thing was missing is the inspection. So those machines are dedicated to inspect all your parts, 100% parts. The technology used is non-contact system. So it allows you to inspect family parts. For brake disc, for instance, you can inspect the smallest brake disc to the big one without changing the configuration of the machine. Then the cycle time is really short. So we cope with production cycle time. For a brake disc, for instance, it's around 20 seconds to inspect one brake disc, dimensional and the defect detection. How does it work usually? Is that the sensors, the laser light sensors are able to extract point cloud, and the expertise of the company is to be able to calibrate all those sensors together and extract a full point cloud of the machine. Usually people are used to have like 10,000 points, and with our solution you will get 18, maybe 20 million data points. Metrology X4 was one of the software able to integrate those point clouds. So you can see here on the screen, you have the CAD model of the brake disc, and then we will integrate all the point clouds on the machine. Just here. So the scan here takes around like 10 seconds to get the full point cloud, and then you will see on the screen that it will be integrated on Metrology. Metrology then will extract all the features that the customer needs. The benefits of this point is that you can do it from your desk. You don't have to stop the machine because it's a production machine, and then you integrate all the features directly in the machine. So you can see here on the screen that all the point clouds were integrated, like here. And then you will get all the data analysis just here.
So once you have finished your execution operation, you will want to manage your results in order to manage your process. In order to do that, we will use our X4 iViewer solution. With iViewer, you will be able to visualize in raw expression or in detail all your results coming from your just measured part on your device. Here is the global view you can have at the end of the execution. You can here have an overview of your results. You are able to retrieve all the defined views during all your inspection process. You can go look at the detail of your results in order to better understand what the issues are coming on your parts. You can, of course, use all our advanced detailed view and all the possibility of analysis and display in order to make your analysis and better understand if your part is really good or if there are some issues during your production. We ensure the analysis of any kind of geometrical tolerances or distance angle evaluation. And you have the possibility to finish the setup of your report inspection in order to send it for printing or PDF file in order to share these results with, for example, your subtractors. Once this analysis job is done, you are able to manage your process in order to correct your production in order to generate better parts. In the end, these results here are visualized with iViewer, but of course these results could be inspected through a statistical tool.
Hello everyone, here we are talking about QDM, the Quality Data Management System. It's an enterprise-wide QMS system where we start from digital transformation of all your digital assets within the company. We standardize it using a process standardization module, so all the quality engineers are looking at the data in the same format, in a meaningful decision-making format. then that allows us to monitor and control your quality within the whole enterprise of your manufacturing plant, and also allows for quality improvement using that quality monitored data for future quality metrics. All this is done with the centralized web-based portal called QDMWEB Gateway. Let me show you a little bit of the QDMWEB Gateway and the key features of the software. Okay, so we're looking at the QDMWEB screen, where we're getting data from all these Metrology tools on the booth, directly sent to QDMWEB with a direct integration. And right now there are 43 samples, and we would like to quickly see a report for the last 10 samples. The system automatically generates a real-time report with CAD graphics, with leader lines pointing to where the measurements were taken, and followed by SPC charts for all the metrics, real-time metrics. So all the quality engineers are looking at the data with a graphical SPC reporting format throughout for all the parts and the bill of materials that's made within the organization. The system also has an inbuilt quality collaboration platform, which allows the quality engineers to interact and collaborate within the QDMWEB system for all the quality problems and all the root causing. For example, in this particular case, there was a mean shift that happened, and the quality engineers put the system on monitor, and then the system was fixed with another quality engineer who went and fixed the process, and now the problem is resolved and the process is stable. All the quality collaborations of process corrections is all stored within the system for future root causing and problem solving. And the third component is a system-wide management dashboard that's integrated within the platform, allows you to look at your entire company on one screen where all the data is coming from. In this particular case, it's the control show. All the data that's coming from the show, it's rolled up, so you can get quality metrics at a system level, at a plant level, at a program level, and at the supplier level. And drilling down to one level at a time, it takes you to the part level, look at your part quality, and from here go to the entire part quality report. So the system has an ability to, as the mechanism to go from a system-wide dashboard all the way to an individual part and its SPC. So this is the overall key functionalities within the system and the key benefits of having a centralized web-based portal to look at your data, look at your quality data. So at the show, we're launching our QDMWEB QI system, the QDMWEB Quality Intelligence System. So the main additions are from our old QDMWEB to the QDMWEB QI is 4 new frameworks that we are adding to the system. One is about a collaboration network, so quality engineers can collaborate for any quality related activities within the QDMWEB system. We also have a product for scan data analysis to take all the data that's coming from scan systems and scan reports and integrate that into our systems and provide an easy to use kiosk. We also are adding another platform for data entry portals and data that's coming from the shop floor from all the manual interfaces, and also another system for live dashboard. So with these 4 new platforms, we are taking our system into a quality intelligence platform, which will be the stepping stone for the AI platform that's coming in a year. So let me walk you through. The quality and collaboration is done using a system called QNotes, allows the users to create quality notes throughout the system for different interactions and allow to communicate with other quality stakeholders. The quality scan is an ability to take in scan data and quality reports into our QDMWEB system and provide an easy to use kiosk to very quickly navigate and look at all your system quality data in one centralized portal. We also are adding data entry portals from within the shop floor. So any manual data that's entered, we provide you a graphical tablet-based interface to load that data using a user-guided system as a part of the QDMWEB QI platform. The QDMWEB QI platform also has live dashboards that could be set up anywhere within the plant for quality engineers to monitor the quality of the products in a live dashboard mode, and it's customizable by the user. So these are the four topics that benefits the customer, and it's unique in the market to provide you with a quality intelligence platform. So here at the show, at Control Show in 2024, we are showcasing our product, QDMWEB QI, integrated directly with Metrologic products. So with what we are demonstrating here is all these devices here, Metrologic tools that are running on the inspection devices, are collecting data. But as soon as the data is collected, they are directly loaded onto the QDMWEB system before the program is completed. So the system can live monitor all the data, and as soon as any of the SPC alerts are triggered, it could send out email alerts to the stakeholders. So with this integrated system, email alerts becomes real time, and systems can be monitored as they are measured on the Metrologic tools. We also are demonstrating another interface component where data that's collected in QDMWEB is providing SPC analysis, and that SPC analysis, it fed back to the Metrologic viewers. So Metrologic viewer can get access to QDM data and provide SPC results to the customers.